This shout out is for Lucy. Would anybody like to say something to Lucy? Okay, Abby would like to say something to Lucy, because Lucy, we know you're going to watch this.
Hi, Lucy. I love you.
Whoa. All right, we broke out the love card. Anybody else you want to say something to Lucy? Come on. Henrik, what do you want to say to Lucy?
Hi, Lucy.
Wow. Taya.
These nuts.
What did she say? There we go. All right, here we go. The area problem. This is the second big question in calculus. Actually, I'm sorry, it's the third one. There's three big ideas in calculus. The first one is limits. The second one is derivatives. And the third one is integrals. But the big problem comes up, what is the area bounded underneath the curve between two lines? That's the question. Just flip to the next page. So that's the big question. What is the area? Yesterday I brought up, it got erased. So the idea of the oil spill, right? How much area did that cover, or how much total oil flowed out if the rate is changing? That's a big question that we would like to discover. So yesterday we had you guys approximate. I need to go get your prizes. But right now, let's begin with an easier example instead of the one that we looked at yesterday. Let's find the area bounded between f of x is x squared and the x-axis and the line x equals 4 by constructing 2, 4, and 8 rectangles. So this will model the first problem that you do on your assignment. What we do is we draw the curve x squared, which looks like that. We are going to bound it by the x-axis, which is right here. And we're going to also bound it by the line x equals 4. What kind of a line is x equals 4? A vertical line. So let's draw a vertical line at x is equal to 4. Yes. Okay. Thank you for pointing out, Morgan, that I did not draw a perfectly straight line. Okay. Next time we'll ask Morgan to come up and show off her perfectly straight lines. It's okay, Morgan. You're better than everybody. I get it. It's okay. All right. Okay. So I'm going to estimate this area. I'm going to do it by making two rectangles. If I have two rectangles in this vicinity, what do you think would be the width of each rectangle? 2 units. I'm going to divide this up into two rectangles. So I'm going to divide it right here at 2. And for the sake of this application, when we look at this interval, we will always draw the height of the rectangle to the right side of the interval. So for example, I will draw the rectangle here and over. And I will draw the rectangle here and over. Better change that, Morgan will get mad at me. That was better. Is that better? We all okay with that? Shut up. Okay. Overestimation or underestimation? Over. Are we all clear by that? I cannot say enough, folks. Everything I say is important. Like when I ask you the overestimation or underestimation, I'm not asking just for fun. I'm asking because you will be asked that question. There'll be an exact question that will come on the AP exam. Get my point? Focus everything that I'm doing here. Everything has importance. Overestimation. Agreed? What is the width of each rectangle? 2. So as I calculate this area, I would have 2 times something plus 2 times something, where 2 is the width, and then I need to produce the height. Agreed? So, what is the height of this rectangle? How do I know? Parent share, talk. How do I come up with the height of the rectangle? Take 1 minute, go, talk. 1 and stop. Okay, somebody with confidence, what's the height? 4. Why is 4 the height, Colin?
4 squared.
Good. So my function is x squared. So if I plug in 2 and I square it, I get 4. That's the height of that rectangle. So what is the height of this rectangle? 16. Is there any question on how I came up with those values? Okay, so 2 times 4 is 8, plus 2 times 16 is 32, so I get 40. Overestimation or underestimation? Overestimation. We all agreed? Please watch how I can change this just a little bit, okay? So I'm going to get rid of the blue, okay? And I know that you're going to struggle to do that in your drawing, so you have to kind of rely on mine to some degree. But I'm now going to make 4 rectangles. What would be the width of each rectangle? 1, yep. So I have 1, 2, 3, and 4. I'm going to draw the rectangle to the right side of the interval. So as you look 0 and 1, notice how I'm drawing the height at 1. That's important, right? Because that's what determines how we get our height. And I go over to 2, 3, and 4. I know part of you right now is like we're finding the area of rectangles, like we've known how to do that for a long time. Okay? Trust me, we're going to do something really cool with it. Okay, so 4 rectangles. So I need the width, which is 1, times the height. What is the height of the first rectangle? How did you get that? You plugged it into the function and you got 1. Good. Plus 1 times 2 squared is 4. Plus 1 times 9. Plus 1 times 16. So notice that as we divided it up, we still came up with the height of 4 and we still came up with the height of 16. Agreed? We added other things to it. The 4 and the 16 are still there. So if we just add these up, we get 1 plus 4 is 5, plus 9 is 14, plus 16 is 30. What happened to our estimation? It was lower. It definitely got better, didn't it? I mean, you know, we definitely cut off some excess area, didn't we? So that was good. If we want to come up with a better estimation, what should we do with our number of rectangles? Let's increase our number of rectangles here. Let's make 8 rectangles. Okay, so if I have 8 rectangles, what will be the width of each rectangle? 0.5 or 1/2. I'm going to use fractions. I'm going to use 1/2. So, and then we would go over to 1, and then we go to 1.5 or 3/2. Then we go to 2, and then we go to 2.5 or 5/2, and then 3.5, which would be 7/2. So what I'm going to do is each of these intervals, I'm going to go to the right side of the interval. We won't always go to the right. So note that we will change that eventually. But I go to the right and I draw those heights. And I think it's fun to do so, just so you can see how the overestimation or underestimation kind of changes each time. You can see that as we draw that, we're getting better, aren't we? That last one really bothers me. It's a lot of overestimation, it appears. But oh well. But it's getting better, isn't it? So, watch me try to save some work for myself. For 8 rectangles, I have the width of 1/2, right? Times, how do I produce the height of the first rectangle? How do I produce the height of this very first rectangle? Take 1/2 and you square it. So I'll write 1/2 squared, right? Oops, sorry. And I take 1/2 times 1 squared plus 1/2 times, what's that? 3/2 squared plus, everybody agree I'm going to continue to do that? What's the last thing I'm going to do? What's the last rectangle? 1/2 times 4 squared. So let's make this simpler. True or false? All the widths are the same. True. True or false? All the heights are the same. False. So let's factor the width out. You see that? So really, it's 1/2 times the sum of the heights. Or in other words, it will be the width times the sum of the heights. So instead of doing the 1/2 every time, we could really just do it once. Does that make sense? We've made it simpler, haven't we? Okay, so to determine the heights, we do the following. You said 1/2 squared, 1 squared, 3/2 squared, 2 squared, 5/2 squared, 3 squared, 7/2 squared, and 4 squared. So that's going to take a little bit longer than our previous ones, isn't it? Okay, so we're going to slice and dice in half. Half is right here. Everybody got it? Half right here. This half of the room, please calculate the red. 1/2 squared plus 1 squared plus 3/2 squared plus 2 squared. This half of the room, please calculate the blue part. 5/2 squared, 3 squared, 7/2 squared, 4 squared. Please compare with a partner. If you're punching in the fraction, please make sure you use parentheses around the fraction when you square it, or it will not work properly. Okay? Go. Okay, can somebody tell me what the red summed to? 2. 3.75. Somebody tell me what the blue summed to. Okay, so I don't have 3.75 here because 2 squared is 4, 1 squared is 5. 7.5? Can we say with confidence 7.5? Okay, very good. Oh, you already multiplied by the half. Got it, thank you. They already multiplied by the half. So let's tally this up. I now have 1/2 times 7.5 plus 43.5 is 51, and 1/2 of 51 is 25.5. Take out your calculator. Let's turn it on. Let's go into y equals. Let us type in x squared. Somehow our calculator does this amazing calculation of the exact area. Let's see how close 25.5 is. We go second calculate. We choose number 7. Great. What's our lower limit? What's our upper limit? 4. Now hold on. I can't see it, but I'm just going to do a little bit of thought in my head. 64 over 3. We're going 21.3 repeating. I could show you guys how to do it in your head. And that will be the calculus. And it will be incredible. We are a ways away from getting there, but the calculator does that. If we wanted this number here to match up with that, what would have to happen with the number of rectangles? We'd have to get more, wouldn't we? Now I want you to watch the incredible calculus disparity that's happening here. This is kind of the cool thing to blow your mind to help you understand. Look at this expression, width, sum of the heights. As we add an infinite number of rectangles, what's going to happen to the sum of the heights? Is it going to get bigger or smaller? It's going to get bigger, isn't it? In fact, it's going to tend towards infinity. You tell me, as we add more and more rectangles, what's going to happen to the width? It's going to tend towards 0. And so this idea of 0 times infinity, if I could bring this just one step further to you guys as we try to calculate this idea, because this is the idea of calculus, calculating the infinitely large and infinitely small. Isn't 0 just another way of writing, say, 1 over infinity times infinity over 1? Haven't we already learned how to calculate that? Remember a guy by the name of L'Hopital? Yeah, so there's different ways in which you learn how to calculate that. So we can do that, but it's a little bit crazy, and that's the beauty of it. Before we're ready to do the calculus part, we have to be good at working with the rectangles. Take out your worksheets. Did I give you your worksheets yet?
No, you didn't.
Okay, I'm going to give you a little bit of time to start the first part of your assignment before we look at the next thing that you have to do with it. But we have a very similar example here. It says, estimate the area underneath this curve. If you don't know what the curve looks like, what could you do? You can plug in your calculator, negative x squared plus 4x plus 7. And as you graph that, you can see it makes what shape? Right side up or upside down? Upside down. So it looks like we got a parabola that looks something like that. Y'all good with that? No. Get a general understanding of what the graph looks like. Where are we bounding it? Over what interval? -1 to 5. So what's the width of that entire interval? 6 units is that entire interval. We would like to start to estimate this area by making how many rectangles? 2. If there are 2 rectangles, what's the width? 3. How did you get that? The width of the interval, which was 6, divided by the number of rectangles. So, at what value would I mark to start making my rectangles? 2. Because that's 3 units there and 3 units there. Are we all okay? So if I draw my first representation, do I draw the rectangle from the left side or the right side? We're saying the right side. So the first one, an over or underestimation? Is the next one an over or underestimation? It's under. You see that? So maybe it kind of cancels each other out. Maybe they kind of, give a good, accurate representation. Who knows? But you just use this formula, the width times the sum of heights. So what's the width? 3. How is it that you'll get the heights? You plug in what? What value? No. No. You plug in 2 and 5. Those are the spots where our heights are determined. Do you see that? You look at the interval and you move to the right side. You plug in 2 and that will give you 1 height. You plug in 5 and that will give you another height. Go ahead, see if you can see the problem the rest of the way. 2 rectangles, 6, 12, so on and so forth. Go. Give you a little bit of time. Folks, if I can have you turn your eyes to the board, let's forget about what the function looks like, and let's just look at this representation of an interval. Suppose that we're finding area of a function from -2 to 3, okay? So, and suppose we want to do 1, 2, 3, 4, 5 rectangles. 5 rectangles. Everybody agree that the width is going to be 1? So, what you do is when you look at each interval, you move to the right side of it when you evaluate the height. So for the first interval, what number will I use to evaluate the height? And then I will use, and then I will use, and then. So what value never gets used? This one, right? Now, later on, we'll change it and we'll say instead of doing a right side always, we will say we will move a left side. And if we did a left side, what would you start with? -2 then? And what value would you not use? 3. See the difference? So right now we're pushing everything to the right. On Monday, we'll introduce it as right-hand sums. We have left-hand sums, we have midpoint sums, we have trapezoidal sums, we have all sorts of pieces that are not that confusing, but we want to make sure we get the right hand first, okay? Take about 2 more minutes. I want to walk around and... Good work. You guys are doing great. You're a great class, great learners. Continue to ask questions. Hold me accountable. Help me out. The more questions we ask, the more I understand, the better teacher I become. I get tired of being a bad teacher. I want to be a good teacher. Here we go. What's different about example number 2? A table. We do not have a function represented as a graph, do we? I don't think that this is going to be a problem for us. It says use the following table to determine an approximate area bounded beneath the function over that interval. I'm going to use 2 rectangles. Can somebody tell me here, what is the width of this entire interval? 8 units. So if it's 8 units, what's going to be the width of each interval? 4. So that means I go from -2 all the way over to 2. Do you understand why some people would say 1? But -2 to 1 is only 3 units, right? So although it's 5 boxes, it's a distance of 4. And then from 2 over to 6. Everybody agreed? So I have my 2 rectangles. All we need to determine is the heights, right? So in order to determine the heights, would I plug in -2 or +2 for the first one? +2, because we are going to the right-hand side. If you plug in +2, what's the output of the function? Ooh, look at that. The function output is 7. This tells you your y values right there. This is your table that you had on your calculator, right? It's just horizontal instead of vertical, right? It's the same thing. So, and then, where do I evaluate my second height? At 6. What's the output? 6. So I have 4 times 7 plus 6, or 4 times 13 is 52. I'm going to divide it into 4 rectangles. If I divide into 4 rectangles, what's the width of each rectangle? 2. So I go from -2 to 0, 0 to 2, 2 to 4, 4 to 6. I only do that so I see my spacing properly. 2 units times, where do I evaluate the first height? And you get 1 plus 7 plus 8 plus 6. So 22. I got 44. We're on the same page there. And then if I do 8 rectangles, what's the width of each rectangle? 1. So again, please notice that how many table values are up here? 9. But how many intervals are there? There's 8. So that's the one thing that sometimes confuses people about that process, okay? So for the 8 rectangles, I have a width of 1, and I am going to, where do I evaluate the first height? At -1. So I'm going to use those values, right? I use everything on the right-hand side. So 10 plus 1 plus 5, 7, 16, 8, 5, and 6. So 11 plus 12 is 23, 33, 39. 39 plus 13 is 52. 52 plus 6 is 58. Anybody confirm? Cool. All right, we end with just one part here. What's different about this one? Anybody? Okay, we'll have some underestimation. That's very good. Anybody else? Are you given a way to compute exact function values? You're going to be estimating your drawing on the y-axis, aren't you? So just understand, if you have this, your answer might not be the same as mine. So as we go 2 rectangles, I'm going to go 2 rectangles. I'm going from 0 to 8. 0 to 8, what's going to be the width? 4. Yes, the width of the entire interval is 8. The width of each rectangle is 4. So I'm going to do a rectangle here, and then I'm going to do a rectangle here. So I draw the height at 4. What's approximately the height at 4? About 9, sure. And if you came up with something a little bit different, that's fine. If you came up with 2, you're wrong. If you came up with 12, you're wrong. It never goes up to 12. So there are things I can look at on your test to say, you know, are they being reasonable or not? Where do I evaluate the next height? At 8. And what do you estimate the height to be at 8? You know, I think 3 or 4 or 5 all could be estimations. I'm going to use 4.5 because I like to be different. I'm a different cat, some people say. 9 plus 4.5 is 13.5, and 13.5 times 4 is 54. I'm not going to finish the 4 and the 8 because I think you get the idea, right? Congratulations, you now understand that first step of calculating the area. On Monday, I want to move on towards left, right, midpoint, and trapezoidal sums. I would rather not look at this, but please come to class on Monday. If you have a question about the assignment, let's go over at the beginning of class. We all good? Awesome, thank you. Way to be